We are starting chapter 5. This one is really mostly about inequalities, and you guys remember inequalities are like less than or greater than type stuff. Okay? So we're going to review those, and then when we get to the end of the chapter, we are doing linear programming, which tends to be a challenge for a lot of people. Okay, so it's not that it's not impossible, but you really need to put everything you've learned about lines and inequalities together, okay? And these are more real life problems of what you would solve in business and stuff like that, okay? So the first thing we're going to look at today is we're looking at inequalities and compound sentences. So a sentence with two clauses and are connected by the word and or by the word or is called a compound sentence. All right. The solution set for a compound sentence using and consists of the intersection of the solution set of the individual sentences. Recall that the intersection of two sets is a set consisting of those values common to both sets. All right. So later in your notes, we have on the right, we have a bunch of lines that have been graphed. And on the left it says this intersection can be described by the single compound sentence of 300 less than or equal to h less than or equal to 400, which is called a double inequality because it has two of these symbols right here. Okay? Recall that the symbol used for intersection is this right here. It's like an upside down U. So that the intersection of sets A and B are written A intersect B. So what I want you guys to look is notice that they took this big sentence, and I'm going to write it again right here just so you can see it a little easier. And they broke it down into three parts. The first part, they are only focusing on this part of the sentence. And they graphed it. Notice that it is a less than or equal. Anytime you have a less than or equal, you're going to have a solid dot. Okay, notice that on this one, I have h on the right side instead. Sometimes it's easier to graph if your variable is always on the left side, so I'm just going to flip them around. You guys see how I just did that? Notice that the larger part of the inequality is with the h on this particular one, okay? So it's easier to graph when I have the variable on the left side of the inequality. Then I know that it's always going to be going larger. The arrow on here is going to follow the arrow on here, okay? So it's a solid dot larger than 300. On this part, notice that, oops, I forgot a zero right here. It is the second half of the equation, h less than 400. It does not have the equal sign there, so therefore it's an open dot. It does not include 400, but it's everything less than it. Okay? So these are the two parts of this sentence that make it up. But now in the last part, we're putting them together. What do they have in common? So I can put solid dot at 300 and go up to 400. So it's basically taking those two sentences, merging them together, the parts that they have in common. Okay? All right. Not sure what's going on here. Let's go on to the next screen. All right. When describing an interval in English, it is sometimes difficult to know whether the endpoints are included. So in this class, we will use the following language. If we say x is from 3 to 4, that's the same thing as saying 3 less than or equal to x less than or equal to 4. It's including 3 and 4. If we say x is between 3 and 4, that's the same as saying 3 just less than x less than 4. So which one has the open dots? The top one or the bottom one? The bottom one has the open dots. Okay? The top one has the equal signs. All right. So let's look at the next part. Compound sentences using the word or. We just finished and. Now this is or. Recall that the union of two sets is the set consisting of those values that are either in one or the other or both. The symbol often for union is just like the letter U, so that should be easy to remember because U starts the word union. The union of sets A and B is written A union B like this. The other way I tell my students in my other class, it looks like a pocket, the union sign. So basically, if you have everything in set A and everything in set B, if you throw them all into the pocket, that's a union. Okay? The solution set for the compound sentence using or consists of the union of the solution sets of individual sentences. So in this particular picture here, they show you two different sets, but they put them in one line. The one set we could say A was less than 2.94, and we could say B is greater than 3.06. The union A union B is this graph right here because they put it all in one graph. Okay? Moving on. So now, we've talked a little bit about unions and intersections. Now we need to talk about how to solve inequalities and review that real quick. Okay? Solving a linear equality is very much like solving a linear equation. The only difference is that when you multiply or divide each side of the inequality by a negative number, and I want you guys to highlight that, you must do what to the inequality sign? Flip it. Yep. Flip it or reverse it. Same thing. I usually use the word flip. Okay? So it changes direction. Here's our first example. Penny Nichols, like the name, get it? Penny Nichols? Has $500 to buy stock options at $17.50 per option. Okay? She wants to stop buying the options as soon as she has less than $100. So what we want to do is first of all set up our sentence for this. She wants to stop as soon as she gets less than $100. So I'm going to put less than right here. Okay? What do you think is going to go on the left side of the sentence? What do we know? What did she start with? 500. Well, how much does it change each time? $17.50, right? Every time she buys a stock, her money goes down by $17.50. Okay? So now I have this set up. I need to solve for x. What am I going to do? Not yet. Yeah, we're going to not divide it, but we're going to subtract it, okay? So we're going to subtract 500 from both sides. We have negative 1750 and then negative 400. So now I need to solve for x. How am I going to do that? Yes, very good. Because I am dividing by a negative number, the inequality is going to reverse direction. So now I have x greater than, it's going to be 22.86.
Isn't it if you divide or multiply in general, doesn't it have to be negative?
It has to be negative. So only when you divide or multiply by a negative number does it flip directions. Okay? Good question. I don't know if I can really explain that right now. All right, so now look. Do you have a 0.86 of a stock option? No. So what am I going to do? Round it up. So I can say X is greater than 23. So she's going to get 23 stock options, okay? Number 2 says, how much money would she have left? No, not 0. So let's plug it in. We're going to take 500, what we started with, minus 1750 times 23. If you put that in, you will end up with, oh shoot, I didn't write it down. I think it's like 99 point something. Let's find out. Of course, I pick up a calculator. It's not working. Okay, so 17.5 times 23 subtracted from 500. That's 97.5. She will have a total of $97.50 left. All right. All right, so now what I'm going to do is we're going to switch to the next problem, and I want you guys to take a moment to try it yourself. There you are. Okay, so you know that the maximum number of tickets that you want to cross over the threshold before you order is 50, right? So that's going to be greater than or equal to 300 minus 2x. If I take 300 away from both sides, I have negative 2x on this side and negative 250 on this side. I divide both sides by negative 2, so what happens to my inequality? It flips, so it should be 125, right? So now, then, the second part says, how many tickets will be left after the first 75 customers? So I'm going to say 300 minus 2 times 75. And that should be 150 for this part. Okay? Your homework.
I don't really get that last part.
I'm just plugging in for X. I'm plugging in 75.
X is
Yeah, number of people. Okay, here's your homework for the weekend.
it up?
Yep, it's up on the Google Classroom.